notes is already there. It is in pen drive. Please, meanwhile, just go through this one. Just go through. I will be back in just 1 minute. Just go through the correlation, the cost and negative correlation. Go through that for 1 minute. Just read that one, or just note on the notes. Back within 2 minutes. So in positive correlation, all the variables are in the same direction, that is positive direction. Okay. So here x values are increasing, means here one variable is increasing. Immediately the other variable also increases. Okay. Yes, document is available. Just I will share this one. I thought that it is missing, but it is not missing. It is there. Yes. Okay, I'm sharing the screen now. Yes. Okay. So this is the actual notes, but it was a mistake. I kept in this other file. So it's now ready. See, in practice, we come across a large number of problems involving two or more than two variables. If two quantities vary in such a way that movements in one are accompanied by the movements in other, these quantities are correlated. That is called a correlation analysis. So there some exist the age of husband and age of wife, price of commodity, amount demanded, increase in rainfall up to a point, and production of rice, etc. The degree of relationship between relationship between the variables under the consideration is measured through correlation analysis. The measure of correlation called the correlation coefficient or correlation index summarizes in one figure the direction and the degree of correlation. So the correlation analysis refers to the techniques used in measuring the closeness of the relationship between the variables. So in correlation analysis, most of the time, two variables are whether they are correlated or not. The close relationships we are going to identify, that is called correlation analysis. For example, you see this one. See here, there exists some relationship between the age of husband and the age of wife. What is the husband age and what is the wife age? Is there any relationship between these two persons? Then prices of commodity. Prices of commodity means what are the prices are there on different commodities and amount demanded. Then increase in rainfall up to a point of production of rice, etc. The degree of relationship between the variables under consideration is measured through the correlation analysis. The measure of correlation called the correlation coefficient and the correlation index. The summarizes in one figure, the degree and one figure, the direction and degree of correlation. The next correlation analysis refers to the techniques used in measuring the closeness of the relationship with the variables. So some of the authors they have given a small definition regarding correlation. That is, according to Simpson and Kaufman, correlation analysis deals with association between two or more variables. Here, two or more variables relationship or the association we are going to find out with the help of these correlation analysis. But according to N.R. Pune, it says that if two or more quantities vary in sympathy, so that the movement, so that movement in one tends to be accompanied by the corresponding movements to the other, then they are said to be correlated. Okay. Then according to Yarlun Chow, correlation analysis attempts to determine the degree of relationship between variables. Yarlun Chow said that correlation analysis attempts to determine the degree of relationship between variables. And according to A.M. Tugel, correlation is an analysis of the covariation between two or more variables. So thus, correlation is a statistical device. See, correlation analysis is a statistical device which helps us in analyzing the covariation of two or more variables. So here the problem of analyzing the relationship between different series should be broken into three steps. They are number one, determining whether a relation exists and if it thus measuring it, testing whether it is a significant, establishing the cause and effect relationship if any. Okay. So then significance of study of correlation. So here these are the significance. Significance means importance. Importance or significance, the meaning is the same. So we are going to see the study of correlation is of immense use in practical life because of following reasons. Because of the following reasons. So the first the importance is here. Most of the variables show some kind of relationship. So for example, there is a relationship between price and supply, income and expenditure, etc. There is a relationship between. Wait a minute. Just read this one and go. So here, most of the variables show some kind of relationship. So here, the relationship between price and supply. So if the price is increasing, and you can check the what is the supply also. If the price is decreasing, and you can check the supply situation. So income and expenditure also. Income and expenditure. What income? How much salary you are getting, and what is your expenditure? So these two relationships we are going to see. With the help of correlation analysis, we can measure in one figure the degree of relationship between existing between the variables. So listen here. The second one. Once we know that two variables are closely related, we can estimate the value of one variable given the value of another. This is now with the help of a regression analysis. So here, see in X variable, some information is given and they will ask the estimate the Y variable. Okay. So with these type of problems, we are going to do with the help of a regression analysis. Then correlation analysis contributes to the correlation analysis contributes to the understanding of economic behavior, aid in locating the critically important variable on which others depend may reveal to the economist the connection by which disturbances spread and suggest to them the path through which stabilizing process may become effective. So here in business, correlation analysis enables the executive estimate cost, sales, prices, and other variables on the basis of some other sales with which these costs, sales, and prices may be functionally related. Some of the guesswork can be removed from the decision when the relationship between variables to be estimated and the one or more other variables on which depends are close and reasonably invariant. Okay, so here sales and price. See, if you see nowadays the petrol price. Okay, what is the petrol price today? Anyone? See, petrol price and the customer. So these two things here we are going to estimate here. So, however, it should be noted that coefficient correlation is one of the most widely used and also one of the most widely abused statistical measure. It is abused in the sense that one sometimes overlooks the fact that correlation measures are nothing but strength of linear relationship, and that is does not necessarily imply a cause-effect relationship. When progressive developments are there here, so in progressive developments here, what happens here? It is nothing but here method of science and philosophy has been characterized by increase in the knowledge of relationship or correlations. In nature also, one finds a multiplicity of interrelated forces. Interrelated forces. Then the effect of correlation is to reduce the range of uncertainty. Is to reduce the range of uncertainty. So the effect of correlation is to reduce the range of uncertainty. Uncertainty means with the help of correlation, we are going to see the certainty only, the confusion, or what is the effect of uncertainty. That gap we are going to fulfill. Okay. So the prediction based on the correlation analysis is likely to be more valuable and near to reality. Near to reality. So here the next one is types of correlation. They are classified according to positive, negative correlation. That is the first one. Simple, partial, and multiple correlation. Number two, linear and non-linear correlation. So these types are number of times asked in the examination point of view. So please take a photo. Why? Because you never get the small definition regarding positive correlation, negative correlation, and simple, partial, multiple, and linear and non-linear. So there are one, two, three, four, five, six, seven types are there, but according to your convenient, I joined all these together at one place. So you see with the example also positive and negative correlation. Positive and negative correlation means here whether correlation is positive, that is a direct, or negative inverse. Direct or inverse would depend upon the direction of change. If one variable is increasing, the other on an average is also increasing. If the same, if as one variable is decreasing, the other one on an average is decreasing. Correlation is said to be positive. So listen here. This you observe carefully. This table. See, 10, 12, 15, 18, 20. So see, it is increasing. See, 10 and 12, it is increasing. 15 increasing. 18 increasing. 20 increasing. In the same manner, so this one also 15, 20, 22, 25, 37. Okay. On an average, it is increasing. So you observe carefully with the help of this small diagram. Okay. Here you have 10, 12, 15, 18, 20. Okay. 10 is here. 1, again 2, 5. So here is 10 here. 10 like this. Then 12, 15, okay, 18, 20. The next one is 15. I think 15 is here. 15, 20, 22, 25, 37. So we are going to see these relationship. Okay. So in this one, see, one variable is increasing, the other variable on an average it is also increasing in a positive direction only. Increasing in a positive direction only. So here positive direction it is increasing like this. Okay, it is increasing. One variable, this is the first variable x variable increasing and y variable also increasing. Okay, so that is called a positive correlation. The next another example is there. See this. To see this one carefully. See, sometimes the value also decreases like this. 80, 70, 60, 40, 30, and 50, 44, 30, 20, 10. See how far these x variable values are slowly decreasing. The same manner, y variable also decreasing. Okay, if on the other hand the variables are varying in opposite direction, one variable is increasing, the other is decreasing or vice versa, correlation is said to be negative. Okay, sir. So here, see, you carefully observe, x variable is increasing here. There's two conditions. X variable is here increasing and y variable also increasing. They are showing the positive direction. Correlation is said to be positive. And here, see, x variables are decreasing, y variables also decreasing. So both the directions, so direction is important here. The both variables are direction positive, the right side, and the negative left side. These type of correlation is said to be positive correlation. On the other hand, the variables are, see, one variable is increasing, one variable is decreasing. See in this way, opposite direction. This type of correlation is said to be negative correlation. See, one x variable increasing, y variable decreasing. X and y, this is opposite direction. This type of they are called a negative correlation. So here you see with the help of these see 20, 30, 40, 60, 80. 20, 30, 40, 60, 80 are increasing, but 40, 30, 22, 15, 10. See, here x variable 20, 30, 40, 60, 80. X variable is positive side. Then you see from this side, that is y variable 40, 30, 22, 15, 10. So this is opposite direction. These type of correlation of type of data, they are called negative correlation. Negative correlation. So here in negative correlation, you observe one more one. See x and y. Here x values 100, 90, 60, 40, 30. See, it is decreasing the x variables and y variables 10, 20, 30, 40, 50. The value is increasing. X is decreasing, y is increasing in the second case. In the first case, x is increasing, y is decreasing. So this type of problem we call it as a negative correlation. Negative correlation. Positive correlation, both x and y values, it is increasing order or decreasing order. That correlation is said to be positive correlation. In negative correlation, x is increasing, y is decreasing, or y is increasing, x is decreasing. So these type of problems they are called as negative correlation. So I think you understood this one, positive and negative correlation. If you have any doubt regarding this two, you can ask. Okay, is there any doubt, students? Anybody any doubt?
No, sir.
Okay. I think you understood positive correlation and negative correlation differences.
Yes, sir.
Okay. So in positive correlation, x value, y value, they are increasing in order, both values, or decreasing order, both values, x and y variable. That type of correlation is said to be positive correlation. In the negative correlation, x is increasing and y is decreasing here. In another case, x is decreasing, y is increasing. So this type of correlation is said to be negative correlation. So by observing the problem also, we can define this whether it is a positive or negative correlation. Okay. So the next one is simple, partial, and multiple correlation. So if you want to take a photo, please take. If you want to write the notes, you can write the notes also. I'll take a screenshot of this one. So this is a small, concise definition. Okay, for your understanding purpose, you can use any example in the examination point of view. So these two problems also take positive correlation. Okay, right. So I'm moving to simple, partial, and multiple correlation. So the distinction between simple, partial, and multiple correlation are based upon the number of variables studied. Number of variables studied means here, see, simple, partial, and multiple correlation says that number of variables studied, number of variables you studied, x, y, z. So in x here, all the values are written here. 1, 2, 3, 4, 5, 6, 7, 8, and 10 are here. 20, 30, 40, 50, 60, 110, 120, 130, 140. Okay. Different values are there. If when only two variables are studied, it is a problem of simple correlation. For example, we are focusing on only two variables. For example, x and y, we are focusing. These type of problems are there. There is no z variable and z values are not mentioned. So immediately we can say that here there is no other variable. We are not considering the z. So here two variables are we are going to study. This type of problem is called simple correlation. Okay. Then when two, three or more variables are studied, it is a problem of other multiple or partial correlation. Okay. Here, see, in partial correlation, what happens? X, Y, Z. So these type of problem we are going to study, that is called partial correlation. See, when three or more variables are studied, it is a problem of other multiple or partial correlation. In multiple correlation, there are three or more variables. First, we are going to study X and Y, then Y and Z and X. This type of problem is called partial correlation. At a time, we are going to study these three variables. They are called multiple correlation. Okay. So the next one is here. See, with the help of example. See, in multiple correlation, three or more variables are studied simultaneously. That is called multiple correlation. For example, here, when we study the relationship between the yield of rice per acre, one variable, and both amount of rainfall and the amount of fertilizer used, it is a problem of multiple correlation. We are focusing on the yield of rice per acre, how much crop we are going to yield, what amount of crop we are going to yield. In the same manner, the yielding of crop, that depends upon rainfall, the second variable. And if rainfall is appropriate rainfall is there and good rainfall is there, all the farmers are happy. They need to apply some fertilizer also, because for rice, while they are the seed is cultivated, for that paddy seed also different variety of diseases will come in a month of 6 months or 4 months time. Why? Because they need to apply fertilizer also. This type of situation also there. So here, see, three aspects we are focusing. The first one is yield of rice. Okay, yield of rice, relationship between yield of rice per acre and the amount of rainfall here, amount of fertilizers used. Three variables are involving here. So it is a problem of multiple correlation here. So the next one is, on the other hand, in partial correlation, we recognize more than two variables, but we consider only two variables to be influencing each other. The effect of other influencing variables such kept constant. So here, see, in multiple correlation, X, Y, Z. At a time, we are going to look after this problem. But in partial correlation, see, these Z will be kept aside. X and Y variables will be studied first, then Y and Z will be studied second, and Z and X will be studied third. So this type of system existed, that is called partial correlation. So for example here, see, you observe the example here. In the rice problem taken above, if we limit our correlation analysis of yield and rainfall to the period when a certain average daily temperature exists, it becomes a problem related to simple correlation. So here, rice problem, in the above rice problem here, what happens? Yield and rainfall, when certain average temperature exists, it becomes a problem related to simple correlation. In simple correlation, we are going to focus on rainfall and yield of rice, or sometimes here temperature also. So this type of situation also there, that is called simple correlation. Okay. Any doubt in these partial, simple, and multiple correlation? See, in multiple correlation, we are going to study at a time simultaneously X, Y, and Z variables. So just I will draw a small example. You listen careful. In multiple correlation, X, Y, Z. At a time simultaneously, we will do the problem. This is X variable. In partial correlation, see X, Y, Z. Three things are given, but we are focusing on X and Y. Then after completion of X and Y, we will go for Y and Z. After completing Y and Z, we will focus on Z and X. Okay, this is a partial correlation. In simple correlation here, X, Y, and Z. Three things are there, but we will focus on X and Y and Z, or Z and X. Any two variables are only we are focusing. We will ignore any one variable, either X or Y or Z. So these type of correlation is called as simple correlation. So I think you understood. I have given the clarity regarding multiple. Okay, any doubt? Anybody?
No, sir.
Okay. So wait a minute. I will take your attendance. So I will take your attendance. Meanwhile, just to read this one, linear and non-linear correlation. Meanwhile, just read this one. So these types of correlation is important for examination point of view. Okay. How many types are there? Three types. What is first one? Positive and negative, simple, partial, and multiple correlation. The next one is linear and non-linear correlation. Okay. So we are discussing. See, in positive correlation, X and Y variables, positive direction or negative direction. Both X and Y variables should go only one direction. It is called positive direction. In negative correlation, X is increasing order and Y is decreasing order. We call it as a negative correlation. Okay, just now we have seen a partial, multiple, and simple correlation. So in linear and non-linear, see the difference here. The distinction between linear and non-linear correlation is based upon the consistency of ratio of change between the variables. If the amount of change in one variable tends to be their constant ratio, the amount of change in other variable is correlated to be linear. So for example, with the help of this example, you can understood here. So in X variable, 10, 20, 30, 40, 50. A difference is 10 only is the difference between all the variables. But in Y variable, 70, 140, 210, 280, 350. So this type of problem is called as a linear correlation. Okay, in X variable, a small difference, but in Y variables, a larger difference is there. But both these two variables are a positive direction only. They are called a linear correlation. So it is clear that the ratio of change between two variables is same. If such variables are plotted on a graph paper, okay, all the plotted points would fall on a straight line. Okay. This is called a linear correlation. Amount of change in one variable, okay, in the same manner in X variable, how it is changed in the same manner Y variable it changes. So the next one is non-linear correlation. See, in non-linear correlation, this correlation, this non-linear correlation is said to be curvilinear correlation. Instead of using non-linear correlation, define linear and curvilinear correlation. Examiner will ask this type of question also to make a confusion. Non-linear or curvilinear, the meaning is same. There is no change in this non-linear and curvilinear. Okay. If the amount of change in one variable does not bear a constant ratio to the amount of change in other variable. Okay. So here, this type of problem is called a non-linear correlation. So here example is there. To see example, if we double the amount of rainfall, the production of rice and wheat would be necessarily be doubled. See, the amount of rainfall is doubled. So today, only 1 centimeter of rainfall is fell. Then tomorrow, it is going to happen the 2 centimeters rainfall. But what about rice and wheat? Whether it is doubled, it is possible or it is not possible. Okay, it may be pointed out that the most of the practical situation we find a non-linear relationship between the variables only. So in practical situation or real life situation, most of the time we are going to see non-linear relationship only. So here, however, since the techniques of analysis for measuring nonlinear correlations are far more complicated than those for near correlation, we generally make an assumption that the relationship between the variables is of a linear type. So this is called curvilinear and non-linear. So I think you understood these one also. Is there any doubt? Anybody? Shall I repeat once again or not? Okay, it depends on you. If you are understood very well, I will move to the methods of studying correlation. Any doubt?
No, sir.
Okay. So I'm moving to types we completed. The next one is methods. So this method is important here. So listen here. The various methods of ascertaining two variables are correlated or not. The commonly used methods for studying the correlation between two variables are there. Here, scatter diagram method is there. Graphical method is there. Carl Pearson coefficient of correlation method is there. Then concurrent deviation method is there. Rank correlation is there. Correlation of group data is there. So these six methods are there generally. So these six methods are very much important, but we are going to focus on only five methods. So from these five methods, I will start Carl Pearson coefficient of correlation method. That is the first, third method. Okay, Carl Pearson coefficient of correlation. That is third method. Yes, complete the problem is there. Yes, all the methods are there here. So we will start the problematic part. Yes. So here, Carl Pearson coefficient of correlation. Just to go through this, I will join in 1 minute. A mathematical method of measuring the intensity or magnitude of linear relationship between two variables series was suggested by the Carl Pearson. So Carl Pearson suggested this one, the mathematical method, to know the relationship between two variables in the year 1867 and 1926, and a great British biometrician and statistician Carl Pearson. So the Carl Pearson's method, popularly known as Pearson's coefficient of correlation. This method is also called as Pearson's coefficient of correlation. Instead of using Carl Pearson's applying Carl Pearson coefficient of correlation, they will use this word Pearson's coefficient of correlation also. So it is most widely used in practice. So the Pearson coefficient of correlation is denoted by the symbol R. Okay, the symbol R here. With this symbol, it is denoted. Okay, uh, it is one of the very few symbols that are used universally. So you go for any formula or any principles. R is the symbol, it is related to current Pearson coefficient of correlation only. Very few universally it is accepted here for describing the degree of relationship between two variables here. So this method is applied only where deviations of items are taken from the actual means and not from the assumed mean here. So you observe carefully the value of coefficient as obtained by the above formula shall be lie between less r in the minus 1. When r is equals to plus 1, it means there is a perfect positive correlation between variables. When r is equals to minus 1, it means there is a perfect negative correlation between the variables. Suppose if you go for calculate, when your answer you get answer is your solution is minus 1 or minus 0.6789. Okay, if the minus sign indicates there is a negative correlation between the two variables, we are going to write the conclusion here. And if it is a plus sign, positive value got, there is a positive correlation between the two variables we are going to write. If you will get a 0, it means that there is no relationship between the variables. However, in practice, such variable r has plus 1, comma minus 1 and 0. Okay. So we normally get the values plus 1 and minus such as 0.8 to 0.26. So we rarely you will get this 1, 0, minus 1, plus 1. But while you are calculating the problem, you will get 0.8, 0.2. So the coefficient of correlation describes not only the magnitude of correlation, but also its direction also. Plus 0.8 would mean that correlation is positive because the sign is R is a plus. Okay, the magnitude of correlation is 0.8. Similarly, minus 0.26 means low degree of negative correlation. So with the help of the following formula, it is very much easier to calculate Pearson coefficient of correlation. So this is a formula. So you observe carefully the formula. R is equals to sigma xy divided by under root sigma x square into sigma y square. Okay. Sigma xy divided by under root sigma x square into sigma y square, where x is equals to x minus x bar and y is equals to y minus y bar. This simplifies greatly the task of calculating correlation coefficient. So take the deviation of x series from the x and the deviation of x. So simply I will go to the problem, then you will get a complete idea. So if you want to write these steps, okay, just to note down, just take a photocopy. There are 6 steps are there, including principle. Just take a photo. Okay, these 6 points are very much needed. So my sincere advice for you is that while you are calculating coefficient of correlation, we need to check 2 things. Sir. So what are the 2 things we are going to see now? So just to read the formula, had the formula, learn the formula, do revision about that formula. R is equals to sigma xy divided by under root sigma x square into sigma y square. This is the most important. Okay. Then next, Carl Pearson coefficient of correlations. Okay, is calculated in 2 methods. I said down just now Two things are there. The two things are, these are the two things. They are actual mean method. Number two is assumed mean method. These two methods are most important. So in which situation we are going to use actual mean method, and in which situation we are going to use assumed method. Now we need to discuss. Why? Okay. So for actual mean method, the formula is R is equal to sigma xy divided by under root sigma x square into sigma y square. So the problems on actual mean method, these are the problems. So you observe the problem here. Calculate Carl Pearson coefficient of correlation for the following data and interpret its values. Yes, are you getting my point? Are you there, students?
Yes, sir.
Okay. So please note down this question, and if you want to solve the problem, meanwhile the class is going on, just note down this one. So this is the only one problem is required to understand the actual mean method. So problem is just like it will be given here. See Carl Pearson coefficient of correlation. So rule number of students 1, 2, 3, 4, 5. See, please ignore these rule number of students. Just consider marks in accountancy, marks in statistics. 48, 35, 17, 23, 47, then 45, 20, 40, 25, 45. Okay. So instead of using a accountancy name, I am going to denote this accountancy as X according to our convenient or according to statistical form. Why this statistics is denoted by Y. Okay, accountancy is denoted as X and statistics is denoted as Y. So these variables are written here. See, rule numbers 1, 2, 3, 4, 5. X variables X 48, 35, 17, 23, then 47. Okay. So next one here. See, these are the X variables and these are the Y variables. Okay. Simply we copied from the question paper itself. And then after what we have to do here, we need to define whether we need to apply actual mean method or assumed mean method. To know that actual mean method or assumed mean method, what we have to do means here, simply with the help of one formula. The formula is here sigma T, sigma x by n, that is x bar and y bar. The averages we need to find out. See, the average of x bar is x average x bar. Okay, average that is 170, 48, 35, 17, 23, 47. 170 divided by 5, that is 34. See, the value is in whole number. 34 is not in decimal or not in the fraction. Okay, this is in the case of y bar. Again, we need to check in the same manner x bar also. Sigma x by n. 175 by 5, that is 35. In the both these two situations, we got a decimal value or we got as a fraction values. Sorry, we never got we got only the whole number value, that is 34 and 35. See, either in the x or in y, 3.4 and 3.5, this value is not repeated. If this value is there means, see, 34 is the whole number, 35 is the whole number. If you got a 34.01 or 34.10, then we can say that here we are going to apply the assumed mean method either in x or in y. Okay. So in these two situations, we got the same value, different values, but the whole numbers. Okay. Then we are going to apply the actual mean method here. Yes, it is clear how to identify actual mean method and assumed mean method. See, in x bar we got 34, y bar 34. These two numbers are whole numbers, not fraction. Fraction means 34.32, 34.12. Okay, then that is a 34. X is equals to x minus x bar. X is equals to 34. See, x value 48 minus 34 plus 14. 35 minus plus 1. See, these 34. Okay, these 34 we got the value from fraction. Okay, fraction value. These sorry, not fraction, whole number value. when we done a calculation that is x bar, you got 34. 48 minus 34 plus 14. 35 minus 34 plus 1. 17 minus 17. 17 minus 34 minus 17. 23 minus 34 minus 11. Okay. 47 minus 34 plus 13. Then sigma x is equal to 0. Then 14 square 196. 1 square 1. 17 square 289. Okay. Then 11 square 121. Then next here 13 square 160. Sigma x square is equal to 776. What is our principle? R is equal to sigma xy by under root sigma x square into sigma y square. So here sigma x square value we got in the same manner xy value and sigma y square value we need to get. Okay. So here first thing, first part that is x we completed. In the same manner, we are going to calculate y also. See, y values are written 45, 20, 40, 25, then 45, then 175 divided by 5, that we got 35. So y is equal to 35. So 45 minus 35, that is plus 10. 20 minus 35, that is minus 15. 40 minus 35, that is plus 5. 25 minus 35, that is minus 10. 45 minus 35, that is plus 10. So sigma y is equal to 10. Then 10 square, 100, 15 square, 225, 5 square, 25, 10 square, 100, 10 square, 100. Okay. So here, this part also we completed. Then x into y. What are the x values? X values are, these are the x values. 14 plus 1 minus 17 minus 11, then 13. These are the x values. Then y values are there here. Okay. 14 into 10. Okay, 14 into 10. See, 14 into 10, 140. Plus 1 into minus 15, that is minus 15 here. Then if 17 minus 17 into plus 5, minus 85, minus 7 into minus 10, minus 2 minus plus, that is 110. Then plus 13 into plus 10, 130. If you do these one, then you will get a sigma xy is equals to 280. Okay, sigma xy value is there, sigma x bar value is there, sigma y bar value also there. So simply we are going to take these values and we are going to interpret in the formula. Just see what is our formula. R is equals to sigma xy by under root sigma x square into sigma y square. So according to formula, we require the values. Here they are calculated as follows. Sigma xy is 280. See 280 here. Then sigma x square is 776. Okay, sigma y square is 550. So these three values are required. For the sake of these three values, we have done these complete table. Okay, so R is equals to sigma xy by under root sigma x square into sigma y square. 280 divided by 776 into 550. Okay, that finally you got the total, the value is R is equals to 0.429. So conclusion here, from the above figure, it is interpreted that there is a perfect positive correlation between marks in accountancy and marks in statistics. So in this way, we need to write. Okay, I think you understood this problem. If you have any doubt, now it is open for you for 2 minutes. If you have any doubt, please ask the doubt. Then if you ask the doubt means, I think that this problem is understood for you. Actual mean method problem here. Okay, so please, you are welcome to ask the doubts. Anybody? Yes. Nobody is speaking. Yes, is there any doubt? Please unmute yourself and answer.
No, sir.
Okay, have you taken this photo also? Are you written in your notebook?
Screenshot, sir.
Screenshot. Okay, good. Right. So this is actual mean method. Okay. Meanwhile, you take another problem also, and you apply. So these here, the important thing here, x bar and y bar. This is the most important here. In these two cases, 34 and 35, you got whole numbers here. Okay, no fraction value and no decimals we got. So 34.5 మనకు రాలేదు, 35 and 34 we got. Okay, sir. So I'm moving to the next problem. So these are the problems for your practice purpose. Okay, take photo. Yes, problem 1 and 2. Take screenshot, and I will show the 2 more problems. On these actual mean method only, these problems are. Okay, so please ignore this case A, B, C, D, E, F, G, H. Year 2001, 2002, 2003, 4, 5, 6, 7, 8. Okay, the next one here, calculate Carl Pearson coefficient of collision. Problem number 3, 4, 5. Please take a photo. Yes, have you taken?
Okay, sir.
Right. So 6, 7 is there. See, 5, 6, 7. These complete actual mean problems are 7 problems are there. According to the first problem, what I just now explained, just prepare the notes. So these problems are compulsory for your examination point of view. You will get more marks out of 16. Okay, for 12 marks or 16 marks. The maximum marks 16 are sometimes for 12 also. The examiner will ask. These problems are big problems. So take photo. Okay, right. So here problems are assumed mean method. So simply I will go to directly the steps here. See, while we are calculating assumed mean method, we need to keep in our mind the following few important points. Okay, the process is same. See, here the process is same. How we done calculations in actual mean method, process is common, and we have to decide by observing the problem. We can calculate the average of x and y variables. X and y variables we need to decide. After calculating the averages, see, this is the most important point here. Average means, in the previous problem we done x bar and y bar. Okay, yes or no? X bar and y bar we have done in the previous problem. In the same manner here also we need to consider x. We need to give importance for x bar and y bar here also. Okay, you observe carefully. See, after calculating the averages of x and y variables, if we got the fraction value, that is 10.12 or 2.10, either in x or in y bar, x bar or y bar, so we are going to follow assumed mean method. If in the previous problem 34 and 35 are the whole number in the x situation, and in y situation they got same. Either x bar or y bar, it is not in fraction or it is not in decimal, that is 10.12 or 2.10. Okay, sir. In two situations, if this thing is repeated, we have to follow assumed mean method. Or in one situation, if this thing is repeated, we have to follow assumed mean method only. So if the average values x and y variables are not in fraction, then apply actual mean method. Okay, previously we done. So this is the formula. Okay. R is equals to sigma dx dy minus sigma dx into dy by n. So please note down this formula. Take a screenshot. Sigma dx dy. Okay, sigma dx dy into sigma dx dy minus sigma dx into sigma dy by n. This is a numerator. Then denominator is here. Under root for both the under root here. Sigma dx square minus sigma dx whole square by n. Okay, sigma dx dy minus sigma dx into sigma dy by n divided by under root sigma dx square minus sigma dx whole square by n. Okay, into under root sigma dy square minus sigma dy whole square by n. Okay, so we will see the problem now. So please take a screenshot regarding this formula. So assumed mean method formula, this is. Okay, I'm going to the problem here. So this is a problem. See, calculate the coefficient of correlation for the ages of husband and wives. age of husband in years, age of wife in years. Age of husband in years, they are 23, 27, 28, 29, 30, 31, 33, 35, 36, then 39. Husband age, then wife age is here 18, 22, 23, 24, 25, 26, 28, 29, 30, 32. See, in actual mean method problem also same it is. In assumed mean method problem also same. It looks same, but see, this is a problem. Observe carefully. See x, y variables. See x values are we have written here, and y values are written here. Okay. Here we need to find out the sigma x value, that is 311, and here sigma y value, that is 257. So we need to find out the first calculate the average of x and y variables to know the actual mean or assumed mean method. So after calculating all the values, then substitute into the formula. So first we are going to calculate the value. So please say the answer. This 311 how much? Anybody? 311 and 257. So the total values are here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 311 divided by 10. How much? Anybody?
31.1.
Yes, 31.1. The average of x bar is 31.1. This point indicates the decimal value or fraction value. So simply we need to go for applying assumed mean method. What about 257 by 10? 257 by 10.
25.7.
Yes, 25.7. See, in the both cases, we got the decimal value or we got the fraction value. So we need to apply the assumed mean method. So here, see, the dx, instead of x, I will write dx is equals to x minus a. A stands for assumed mean method. That is, we can take assumed mean method. You can take any value out of these 10 values. That is your option. Sir, you have taken 30. That is a place 1, 2, 3, 4, fifth place. Okay. You take any place. Either you take 23 or 27 or 28, 29, 30, 31, 33, 35, 36 or 39. That is your wish. Okay. Assumption value is our wish. So this problem I have taken 30 is assumed mean. From the problem only I have taken 30. Okay, so 23 minus 30, that is minus 7. 27 minus 30, that is minus 3. You observe carefully this one. And now I am doing the difference between these values. 23 minus 30, minus 7. 23 minus 30, minus 3. 28 minus 30, minus 2. 29 minus 30, minus 1. 30 minus 30, that is 0. Yes. 31 minus 30, 1, 3, 5, 6, 9. Sigma dx is equals to 11. Okay. Then dx square. 7 square, 49. Here. 7 square, 49. 3 square, 9. 2 square, 4. 1 square, 1. 0 square, 0. 1 square, 1. 3 square, 9. 5 square, 25. 6 square, 36. 9 square, 81. Sigma dx square is equals to 215. 215. How we done the husband age, that is dx and dy, in the same manner we are going to do for wife age also. So these are the values we have taken from the question. Okay, and assumed mean is 25. The condition is that in x variables, the place, the fifth value we have taken for our assumption. The same manner take in the y variable also the fifth place. Sir, I will take only the first place. That is your question. So take x variable. In x variables, first place means y variable also first place. That is your choice. You can take any value. That is the assumption value. Okay. So here 18 minus 25, that is minus 7. 22 minus 25, that is minus 3. See, red in line, that is assumption value, assumed value you have taken. So finally dy is equals to 7. Then 7 square, 3 square, 2 square, 1 square, 1 square, 3 square, 4 square, 5 square. 7 square. dy square is equals to 163. Okay. So here dx into dy. Already we got a dx value and a dy value. Dx values are these values and dy values are these values. 7 sevens are 49, 3 threes are 9, 2 twos are 4, 1 ones are 1, 0 into 0 0, 1 into 1 1, 3 threes are 9 9. Okay, then finally dx dy is equal to 186. So what is our formula? Sigma dx dy minus sigma dx into sigma dy by n under root sigma dx square minus sigma dx whole square by n. Okay, into under root sigma dy minus sigma dx, sorry, dy whole square by n. So this is the formula. Okay, so according to this formula, all the values are there here. So sigma dx dy is equals to, see, sigma dx into dy is equals to almost 186 here. Okay, 186 here. So dx value is 11 and dy value is 7. By n is, n stands for number of variables, that is 10. Okay, so in this formula we are going to take all the values and we are going to calculate. Then finally the value we got, that is r is equals to 178.3 by 179.10. That is 0.98. So here I have taken 7 steps. Okay, you can take 1 steps or 2 steps, that is your choice. Okay, Nana? You can take your choice. So from the above figures, it is interpreted that there is a perfect positive correlation between husband age and wife age. Okay. So in this problem, if you have any doubt, please ask the doubt. Anybody, any doubt? If there is no doubt, means I will show some problems. Take the screenshots, or you take these problem of a screenshot. So this is the solution. Take screenshot. And here this is the formula. First step. The second step, all the values are kept here. The calculation is done. Okay. Any doubt regarding assumed mean method? Anybody? Yes. No answer from your side. Are you there in the class?
Yes, sir.
Any doubt?
No, sir.
Okay. So take the screenshots of for the practice purpose. Here are some problems on assumed mean method. See problems for practice. 1, 2, 3, 4. 1, 2, 3, 4. Yes. I will go next. I will show next slide.
Yes, sir.
Yes. 5, 6. See 5. Problem number 5. Take this. Wait a minute. Yes, take this one. 1, 2, 3, 4 you have taken now. Just again take number 5. Okay.
Okay, sir.
Right. So wait a minute. Listen here. In the problem number 1, 2, and 3, they are the same problems. But problem number 4 and 5, you observe carefully. Calculate Pearson's coefficient from the following data using 44 and 26 respectively has origin of x and y. Okay. Sometimes examiner will give the value 44 and 26. If you go for calculation, you will get x bar value and y bar value has a whole number. Then you need to do actual mean method. But examiner in advance, he will mention the number 44 and 26. Okay, and 65 and 70 in problem number 5. Take these values as deviations and do the problem. Okay, this is also one of the important conditions. But if these values are mentioned, when you do the problem, you will get x bar value and y bar value as a whole number. Then actually which method we are going to do? We need to do actual limiting method. But the condition is that 44 and 26 and this 65 and 70 they have mentioned in advance. Okay, so we have to follow this one only. Yes, Redmi 75 raised your hand. What happened? Any doubt?
No, sir.
This person, Redmi, who is Redmi Note 75? Please unmute and you ask the doubt. Okay, this is Carl Pearson's coefficient of correlation. So we have only 5 minutes time. When is our next class?
Next Saturday, sir.
Yes, next Saturday I will start this rank correlation.
Okay, sir.
Is there any doubt in correlation? This one, Carl Pearson coefficient of correlation?
No, sir.
Okay. So meanwhile, practice that problems. If you have any doubt, you are welcome to ask in the next class regarding doubts here. Okay. So rank correlation, I will show a small overview regarding rank correlation. So this is Pearson rank correlation coefficient. This is also one of the important topics. This topic was given discussed by Charles Edward Spearman. He's a British psychologist. He developed this method. So this is a formula 1 minus 6 sigma d square by minus n minus n into n square by minus 1. So in this rank correlation, see observe carefully. The problem of rank correlation are as two types. Problems when actual ranks are given, problems when ranks are not given. Okay, so ranks are given and ranks are not given. These two methods we are going to discuss in a rank correlation. So here problems first method is observed carefully. Problems where actual ranks are given. See, ranks are given, ranks are not given. So this is a problem. Ranks, see rankings based on the efficiency of 10 employees working on two production coefficients. Student A, B, C, D, E, F, G, H. Process 1, 2, 10, 12, 1, 4, 3, 6, 5, 8, 9, 7, 9, 4, 2, 3, 1, 5, 6, 8, 10, 7. So in this way ranks are given. They will ask calculate the coefficient and rank correlation, comment on the value. Okay. So in this way we have to just to see the problem. If you want to take screenshot, take the screenshot also. See rank of competition of rank correlation between process 1 and process 2. Employee A, B, C, D, E, F, G, H, I, J. Okay. Then the ranks, how the question is given, simply we are going to copy the question simply. See, ranks are given here. 1 here, 2, 3, 4, 5, 6, 10 here. Okay, then that is Xi and Yi. There also ranks are given. So rank for Xi, see, ranks for Yi. So the bigger number in the place of 10 have given first rank. In the place of 9 have given second rank. So the person who got more marks, then only we are going to give ranks in school. In the same manner here also, we are going to give the ranks here. Okay, the ranks are given for Xi and Y also ranks are given. Then Di is equals to Xi minus Yi. Okay, so 1 minus Xi minus 2. 1 minus 2, that is minus 2. Then 9 minus 7 minus 2. Okay, so here 10 minus 9, 1, 7 minus 8, that is my, here 1 minus 2. So just focus on these values. So we got here D value, that is 0. So by giving the Di square, that is 1 square 1, 2 square 4. Okay, minus 1, 2 square 2. Okay, and finally here 2 square 4. D square is equals to 15. Okay, so since n is equal to 10, sigma d square is equal to 15. Apply the above into the formula. You get the formula is here 1 minus 6 sigma d square by n into n square minus 1. Okay, finally we got the value is 0.90. The high positive value of rank correlation coefficient indicates that there is a very good amount of agreement between process 1 and process 2. So in this way, we are going to do rank correlation. So this is only a small overview. In the next class on Saturday, just to remember once. Okay, so we completed correlation topic completely. In correlation analysis, there is no doubt regarding actual mean and assumed mean. In correlation analysis, the second topic is rank correlation. So please, on that day, when on Saturday, next Saturday, I will ask you regarding these homework problems. Homework problem means some practice problems have given just now. That practice problem you have to do practice, and everyone you have to come with answers. Okay, so I will join on Saturday at 1:30. Okay, meanwhile practice that problem compulsory. If you do practice, then only you are going to get a complete grip on the actual mean method and assumed mean method problems. Okay, so I will winding up now today. So in the next class, I will start once again the rank correlation topic. It is a fresh topic in correlation analysis. If time permits, on that 2 days, that Saturday and Sunday, we are going to complete. Wait a minute, I will share this syllabus answer. See, correlation analysis. In that correlation analysis, we are going to see till here we completed here. See, methods of studying correlation. This or these three lines: positive correlation, significance, negative, everything we completed. Carl Pearson coefficient of correlation also we completed here. So scatter diagram is balanced, correlation graph is balanced, rank correlation is there, rank correlation and concurrent deviation. So in the next class, concurrent deviation, rank correlation on Saturday we are going to complete just within half an hour. Okay, I will try to complete that one. So then after I will go for a regression analysis. Okay, from regression, topics of regression also we have only 2 more classes. So I will focus on the important topics. This say from block in the block number 3, 10, 11, 12 are problematic only. Okay, I will focus on important points only. Then the block number 4, 13, 14, 15, 16, 17, and 18. These are the important topics. These are the problematic part also. Okay, so we are going to see that one. And in statistical quality control also, these are also important topics. So in the how many classes till today? How many classes we completed?
4, sir.
Only 4, and we have 4 more classes. In these
Yes,
4
sir.
more classes, we are going to complete the syllabus. Complete syllabus are up to the mark. We'll try. Okay, how much, what amount of classes you have taken? That class should be 100%. I will make you sure. You need to learn. That's all. Okay. In a hurry situation, in these less classes, either cook or cook, simply just going on reading and showing that different slides. That is not good. But what is my intention is that you need to understand the problems which are delivered by me. That is the main aim of the teaching. That is the reason only. Slowly we are focusing on the topic which we are focusing. That topic should be enter your brain. That is the most important. So the practice questions, please try to practice the questions and come with the solutions on the next class. Okay. So thank you.
Okay, sir.
Right.